today we're going to be looking at not so simple harmonic motion, which is going to include shifts, horizontal and vertical, as well as our amplitude and period. So let's read problem number 1. In Savannah, Georgia, high tide reaches a depth of 13.2 feet and occurs 3.5 hours after midnight, while low tide reaches a depth of 2.2 feet and occurs 9.75 hours after midnight. So our two variables that we're going to label on our graph is we have time, which is in hours, and this is hours after midnight, so I'm going to write that. And we also have our high tide, so this is the depth of our tide, and our low tide. So this is measured in feet. So your tide, we see that the high tide reaches a depth of 13.2 feet. So this is the highest our tide reaches, and the lowest it reaches is 2.2 feet. So I'm going to label that on my y-axis. I have 13.2 and 2.2. So that's the highest and lowest my tide reaches. I know that the high tide reaches a depth of 13.2 feet at 3.5 hours after midnight. So hours is now my x-axis. So I have 3.5 and 9.75 hours. I'm going to plot those on my x-axis. So at 3.5 hours, this is when your tide is at 13.2 feet. So I'm going to plot a point right here. And then at 9.75 hours, this is when your tide is at 2.2 feet. So that means this one is down here. Okay, so if I connect this, I can tell this is the highest, this is my lowest. This is only half of a cycle, so let me continue to draw my entire cycle. And this is the sketch I'm going to use to write an equation for my problem. Okay, so this is my max and my min, so this is what I'm going to use to find my A. So to find my amplitude, I do max minus min divided by 2. So 13.2 minus 2.2 divided by 2. So I'm going to make sure I put this in parentheses if I'm plugging it all in at once. And this gives me 5.5. So this is my amplitude. To find my period, I first need to figure out what is the distance between high tide to low tide. So we know these two numbers, from 3.5 to 9.75. This is 6.25. But this isn't my entire period, right? I want my period to go from high tide to the next high tide. So if I know that this is 6.25, this is only half of it, to figure out the whole thing, I'm going to take 6.2 and multiply it by 2. And that's going to give me my entire period, which is 12.5. Okay, knowing my period, I can now find my value for B. So I have 2 pi divided by 12.25. And next I'm going to find my K, which is max minus amplitude. And the maximum value here is 13.2. My amplitude is 5.5. And that gives me a value of 7.7. Okay. Finally, I'm going to pick which of these points I'm going to use to write my equation for this graph. So if I decide to pick this point right here, this is the top of a hill, which means that this is going to be a cosine function. So I have, my amplitude is 5.5 cosine. This is a positive cosine because it's starting at the top, so this is a positive. Open parentheses, I have my B value, which is 2 pi over 12.5. I need another parentheses, x. So in this case, if I'm picking this point, from the y-axis, I've moved to the right this number, 3.5. So if I move to the right, I'm going to be subtracting 3.5. Make sure you close both of these parentheses, and then we're going to add our k value, which is 7.7. And this is my equation. So now we're going to graph this in our calculator. So we're going to go to y equals, type this in, be careful with your parentheses. And then we're going to go to window. So on our window, my x min, I'm going to start at 0 because that's where this graph starts. For x max, I want to pick a number that's like way over here somewhere. It's got to be bigger than 9.75. So let's say we just use 15, just to be safe. And then for my y's, I wanted to include these two numbers, so again I'm going to start at 0 for my y minimum. For my y max, I want it to be above 13.2, so again let's just use 15. So I'm using 0, 15, 0, 15, and then graph it. And so to check to make sure our equation is right, let's just make sure that these 2 points, the ones that they gave us in the problem, are correct. So I'm going to press trace, and then I'm going to type in 3.5, so it says x equals 3.5. When I press enter, it should give me this point right here. So I have 3.5, 13.2, that's correct. Let's now type in 9.75 and see if that gives you 2.2. Yep, this gives you 2.2, which means my equation is correct. So this is a good way of checking to make sure you entered your equation right into your y equals before you move on to the next two problems. Okay, so let's look at part C. What was the water level 23 hours after midnight on that day? So we know hours is our x value, so we're looking for when x is equal to 23. So right now, if I were to just do trace x equals 23, it's going to give me an error. The reason why it's giving me an error is because this is not in my window right now. So I need to go back to my window. Notice if I want x to be 23, right now my x max is 15. So this is not a part of my window because 23 is bigger than 15. So I want my x max to be something that's bigger than 23. So let's just say, let's make it 25. And then I'm going to graph it again. And this time 23 is going to be a part of this window. So when I press trace, it's going to work. So we're waiting for this to graph. Let's press trace as soon as it's done. Type in 23, and it'll give you your y value, which is 2.586, 3 decimal points. And this is our y value, so this is feet. Again, don't forget your units. Okay, so for part D, the question asks, when was the second time that the tide reached 11 feet? So this is not asking you about your y value. So we're looking for when y is 11. So to figure out when y is 11, we're going to have to go back into our y equals and type in 11 for our y2. So once you have y2 equals 11, we're going to graph that. And now there should be a line drawn through your graph. We're looking for the second time that the tide reached 11. So not this first one, but the second one. To find this, we're going to use second trace, and we're going to go to intersect, so number 5. Once I press number 5, I now need to move my cursor over, so I'm going to use the arrow button and move it over so that it is right on top of the intersection point that I want, the second one. So once it's blinking on top of that, now I'm going to press enter, 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 and it should now say intersection, and it gives me my x value and my y value, which is 11. So my answer is the x value, which is 5.345. We're going to round that. And because this is your x value, this is a units of hours. And this is hours after midnight. Cool. Okay, so let's look at our second problem now. The number of hours of sunlight in a day can be modeled with a sinusoidal function. The longest day of the year occurs on the summer solstice, while the shortest day of the year occurs on the winter solstice. So in Boston, the number of hours of sunlight on the summer solstice is 15.28, which is on day 537.5. And on the winter solstice, which is day 355, there's 9.06 hours of sunlight. So let's label our graph. So we have time, which in this case is by day. And then we're looking at our hours of sunlight. So sunlight in hours. Okay, so on our hours, our y-axis, the two numbers that we have to plot are our max, which is 15.283, and then our minimum, which is 9.067. On our x-axis, we have day 355 as well as day 537.5. So our maximum 15.283 is occurring at day 537.5. So up here, this is our maximum. We're going to plot a point right there. The minimum of 9.067 is occurring on day 355, so that one's down here. So again, we're going to connect it. We want to draw a full cycle. So right now, this is only half of a cycle. So if it starts down here, I'm going to draw it, have it end over here. So we're going to have to look for another point right there. Okay, so let's first find our amplitude. So amplitude is max minus min over 2. So again, when I put this in the calculator, make sure you have parentheses around that numerator. And you get an amplitude of 3.108. Now let's find our b. So b is 2 pi divided by our period. To find our period, so let's first find this distance from 355 to 537.5. So right now this is 182.5, but again, this is not your entire period. To find the whole period, since this is only half of it, we have to multiply that by 2. So when we multiply that by 2, we get a period of 365. And so our b value is 2 pi over 365. Now to find our k, k is max, 15.283, minus our amplitude, which is 3.108. And that gives us a value of 12.175. And now to write our equation, we just need to pick a point. So let's use this point right here, the first point we're starting at. So if I'm using this point, it's starting at the bottom. So this is going to be a negative cosine function. So this is negative. My a value is 3.108 cosine. My b value is 2 pi over 365. My h, so right here, if I'm using this point, I've moved to the right 355, which means I'm going to be subtracting 355, close parentheses. And then, of course, I'm going to add my k, which is 12.175. So this is my equation. I'm going to go ahead and put this into my y equals. So let's clear this. Negative 3.108 cosine 2 pi divided by 365, open parentheses, x minus 355, close parentheses, and then plus 12.175. Okay, so after this we're going to go to window. For my x min, I'm going to again start at 0, but since my greatest number is 535, I'm going to pick a number bigger than that, so let's just do 550. For my y, I'm going to start at 0 again. I want something bigger than 15.283, so let's just use, let's say, 18. And now let's graph it. So again, just to check to make sure that my equation is correct and that I typed it into my calculator correct, I'm going to spot check these 2 points right here. So I'm going to press trace. I'm going to first type in 355, and that should give me 9.067, which yes it does. So far so good. And then I'm going to type in 537.5, press enter, and that should give me 15.283, which again, yes it does, which means that my equation is correct. So now we can use this to answer our last questions. How many hours of sunlight were there on day 263, which is September 2nd? So day tells you this is your x. So we're looking for what is your y when x is 263. So we just press trace, type in 263. It gives you your y value, which is 12.215. And this is your y. So this is hours of sunlight. And then for March 1st, this again is a day, so day is y, x equals 60. So trace, type in 60. It gives you a y value of 11.063 hours. And finally, when are there at least 12 hours of sunlight to the nearest day? So at least 12 hours, now this is your y value, because hours of sunlight is y. And at least tells you you want it to be greater or equal to. Because if you have to be at least this tall to ride the roller coaster, you have to be that tall or more. So now for our y, we're going to go into y2 and type in 12. It's going to graph a line. And greater than or equal to means above this line. So I'm just going to look at this first time right here. This is when it is above your line. So I need to find these two intersection points. So let's go to second trace, intersect. Let's find the first one. So I'm going to move my cursor all the way over to this first one. Enter, enter, enter. I get an intersection point of 77.977. That's my first intersection point. I'm going to go and find my second one now, so second trace, intersect. Now I'm going to move my cursor over to this one. Again, press enter, enter, enter. This gives me an intersection point of 267.023. And so the question is asking when are there at least 12 hours, so when is it more than that? It's going to be more than that in between these 2 points. So between 78 and 267 days. So because it says to the nearest day, that's why we're rounding it to the nearest whole number. So yeah, between these two is when it's going to be greater than or above this line, which represents 12 hours of sunlight.